Do you feel the vibes?
All right, let's take a look at section 5. This section is on variation functions. We're going to start talking about direct variation first. Basically, what direct variation is, it relates to quantities, right, that when one increases, the other one also increases, or when one decreases, the other one also decreases, right? So for example, let's say there are two things, right? X and Y. And suppose when you double X, Y also doubles, right? That's direct variation. When you multiply X by 3, Y gets multiplied by 3. When you divide X by 5, Y gets divided by 5. Okay, this is direct variation. Mathematically, we say Y varies directly as X. Okay, that's the term. Y varies directly as X. And what does that mean? If there is a constant K such that Y equals KX, right? Let's take a look at this. Y equals KX. Here's X, here is Y. If I multiply X by 3, what will happen to Y? 3 times bigger. If I multiply X by 7, what happens to Y? 7 times bigger. That's direct variation. If K is a half, if I multiply X by half, what happens to Y? Half as small, all right? That's direct variation. So, there is another way to say this, which is y1 is kx1, y2 is kx2, meaning, so if you have, look at this, if you solve this for k, what do you get? Y1 over x1. If you solve this for k, what do you get? Y2 over x2. So another sort of what comes out of this is whenever you have a coordinate point, right? Whenever you do y equals x, for that function, you're always going to get k. All right? Yes.
Is the one below, is that like the logarithm thing?
No.
Oh, so that's just
correct.
Is it? It's like the different like y.
Yeah. Why don't I teach a little bit and you'll see exactly what I mean. So another way so if y1 over x1 is equal to k, and if y2 over x2 is equal to k, then I can also say y1 over x1 is y2 over x2. Okay? All right. So let's take a look at a function, right? Let's explore this a little bit more. Suppose I have y equals 4x. Okay? Let's get some table of values for this. All right? Let's say x is 1. What's y? X is 2. X is 3. What is it? 12. Okay? So take a look. These are all points from a function that has direct variation, right? So take a look at the first coordinate point. If I multiply y divided by x, what do I get? Y over x, I get 4. Here, if I do y over x for this one, what do I get? 4. If I do y over x for this one, what do I get? 4. Do you see what direct variation functions are like? No matter what coordinate you get that is from that function, their relationship is always going to be, y over x is always the same value. Okay, so if y varies directly as x, okay, and y is 15 when x is 15 and blah, 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 blah. Okay, I read this phrase, the highlighted phrase, y varies directly as x. As soon as you read that highlighted phrase, you know that the equation for that is y equals kx. Okay? You immediately write that. And then you move on. Now it says, y is negative 15 when x is 5. That's one bit of information that goes together. So why don't we plug those in? Y is negative 15 when x is 5. So let's find k. What's k? Negative 3. It says find y when x equals 3. So let's use the equation again. Now, y is equal to negative 3x. So when x is 3, y is negative 3 times 3, y is negative 9. Okay? Now, another way to do this is the following. We said y varies directly as x. Another thing I showed you before was y1 over x1 is equal to y2 over x2, right? So with this, if you're not directly asked to find k, you could also do it this way. So y1, x1, the red ones go here, negative 15 over 5 equals y2 over 3. And then negative 45 is equal to 5y2. So y2 is negative 9. All right? Same sort of situation exists there too. You can do it both ways. If you're explicitly asked to first find k, you got to do it this way. If not, you can do it this way because this intercepts the whole k thing. Okay? All right. Now, what if you have what we call joint variation? Joint variation is when one quantity varies as the product of two variables. For joint variation, this is the formula. Y equals k times xz. All right? So, take a look at this example now. So, suppose y varies jointly as x and z. You read that sentence and you say y equals k xz. So y varies, this is the y equals k part, right? And then x times z. So now find y when x is 10 and z is 5. So let's go ahead and plug those in. So if what do we have? Y is 12 when z is 8 and x is 3. So let's go ahead and plug those in. So y is 12, k times 3 times 8. Okay, so 12 equals 24k. K is equal to a half. So my equation is y equals half xz. Cool? Okay. So what's y now? Half times 10 times 5, 25.
Is k a constant?
Yes.
Z isn't a constant.
K is a constant. K is always a constant. Z is never going to be constant because it changes. Yes.
What does K actually represent?
A constant. It's the constant of variation.
It's not like
It's called a constant of variation. Okay, now let's talk about inverse variation. Inverse variation is exactly what we're talking about, but opposite. This is when if you double x, y gets divided by 2. Okay? So as one increases, the other one decreases. And the reason why I was talking about gas laws before is because they follow, like there's one where, like temperature and volume follow direct variation, right? And then, pressure and volume follow inverse variation. But you'll see that. So here, when the product of two variables equals a constant, then they are said to vary inversely. So what I want you to remember is this one. Y equals K over X. For direct variation, we had Y equals K times X. This one is Y equals K over X. Okay? So now look at this. If X varies inversely as Y, when I hear that sentence, Y equals K over X. Okay? So when I read X varies, this is Y equals K. And then after that, if it's directly, it's times X. If it's inversely, divided by X. And how do you keep it straight? You can always like figure it out, right? Like if you have an equation like this, think to yourself, as X gets bigger and bigger, what happens to this whole fraction? It goes down. Okay, that's an inverse variation, okay? Whereas over here, if X gets bigger and bigger, what happens to Y? It also gets bigger. That's a direct variation. All right, so here, X is 24 when Y is 4. So let's go ahead and plug that in. 4 equals K over 24. So how much is K? 96. Find X when Y is 12. Okay, so Y equals 96 over X is the equation. So 12 equals 96 over X. 12X equals 96. So how much is X? 8. All right? Okay. The length of a violin string varies inversely as the frequency of its vibrations. Boy, do I know that, because I'm always hearing violin at home. Okay? So yeah.
Would length be X?
The length of a violin string varies inversely as the frequency of its vibrations. So that means Y equals, whoops. Okay, so take a look. Y equals K over X. A violin string 10 inches long, that's Y, vibrates at a frequency of 512 per second. Okay? So 10 is equal to K over 512. So K is 5,120. Okay, so what's the equation then? Y equals 5,120 over X. So now we want to find the frequency of an 8-inch violin string. So 8 equals 5,120 over X. 8X is 5,120. So X is 640, right? So it's 640 cycles per second. And if you know any music, right, what is A? It's 440 hertz, right?
Oh no.
Come on, who plays music here? A. When you tune to A, it's 440. So this is 640, so it's a higher note. See? Now I can't hear the 640 to save my life. Like I don't know the difference between an A and a C and a G. I can't hear it. I can't hear the difference. Like if somebody plays and they're like, is that an A? I'm like, I don't know. And then if they play something else and they're like, is that higher? I'm like, oh. But I can tell you exactly how many cycles per second it is. Let me tell you. Yeah. Okay, go. Suppose F varies directly as G, right? This means F equals KG, correct? And F varies inversely as H. That means F is K over H. So that's how they all combine. Okay? So take a look at the blue. F varies directly as G. That's what we were doing. F varies inversely as H. That's K over H. Combining together, that's what it looks like. Okay?
That's legendary.
So, now, find G when F is 18 and H is negative 3 if G is 24 when H is 2 and F is 6. So you always have to find the one that gives you most information, plug it in, and get your K. So in this case, F is 6 equal to K times 24 over 2. So 6 equals 12K. K is a half. So F is K times G over H, right? I can also write it like that, right? So F is 1/2 G over H. And what do we need to find? G when F is 18 and H is negative 3. Okay? So 18 is equal to G over negative 6. So G is negative 108. Yeah.